Hello, I'm Essay, your AI essayist. Please note that all content, audio and video in this presentation are AI generated. As AI can sometimes produce inaccuracies, I encourage you to verify any factual information presented. With that in mind, let's begin.
The mid-19th century witnessed a profound intellectual ferment, a period of intense scrutiny of the natural world. The prevailing scientific ethos grappled with a fundamental question: the origins of life and the age of the earth. Traditional viewpoints, often rooted in religious doctrine, posited a static, divinely created world. Yet, accumulating geological evidence, painstakingly gathered through the work of dedicated naturalists, presented a different narrative, one of immense time scales and dynamic transformations. It was within this context that Chambers Robert, a publisher and writer, emerged as a pivotal figure, albeit one whose contributions were often misunderstood at their time. He was a man whose work, despite its imperfections, dramatically shaped the public's engagement with the evolving scientific landscape. Chambers Robert's most significant contribution resides in his popularization of transmutation, the idea that species are not immutable but change over time. This concept, then a nascent and controversial one, was presented to a broad audience in his anonymously published work, Vestiges of the Natural History of Creation, which appeared in London in 1844. This book, a landmark in the history of science, offered a comprehensive narrative of the cosmos, from the formation of the solar system to the development of life on Earth. Chambers' achievement lay not in original scientific research. He was, after all, an editor and publisher, a man whose primary expertise lay in the dissemination of information, but in his skillful synthesis of existing scientific ideas and his presentation of them in an accessible, engaging format. The challenge he addressed was the chasm between emerging geological findings and the deeply ingrained creationist paradigm. Geologists, such as Charles Lyell, were already demonstrating the vast antiquity of the Earth, a timescale far exceeding the traditional biblical chronology. This presented a problem: if the Earth was ancient, why did its inhabitants appear to be static? Chambers sought to bridge this gap, proposing a framework in which life, too, underwent a process of gradual development driven by natural forces. He argued that the fossil record, with its sequence of increasingly complex organisms, provided evidence for this progressive unfolding. He constructed a narrative in which life advanced through a series of stages, culminating in the emergence of humankind. Chambers did not offer a fully articulated scientific theory in the modern sense. He lacked the experimental rigor and detailed observational data that would later characterize Darwin's work. His approach, however, was groundbreaking in its scope and ambition. He wove together geological evidence, observations of embryological development, and speculative analogies to create a compelling, if sometimes flawed, argument for the transmutation of species. His framework suggested that environmental pressures, coupled with an inherent tendency toward progress, propelled life along a predetermined path. This was a concept that resonated with many, even if the specific mechanisms he proposed were later proven inaccurate. The impact of Vestiges was immediate and far-reaching. The book became a bestseller, capturing the public's imagination and sparking widespread debate. It reached a readership far beyond the confines of the scientific community, influencing novelists, poets, and even the general public. This widespread dissemination of scientific ideas was a unique achievement. Chambers, through his publishing acumen and his talent for crafting an accessible narrative, brought complex scientific concepts into the public sphere. He facilitated a cultural shift, fostering a climate in which the idea of evolution, previously confined to the fringes of scientific thought, could be seriously considered. A key influence on Chambers was the work of Charles Lyell, whose Principles of Geology had revolutionized geological thinking. Lyell's emphasis on gradualism, the idea that slow, continuous processes could produce significant changes over vast periods, provided a crucial foundation for Chambers' ideas. Lyell's work, however, primarily focused on geological phenomena. Chambers, by extending the principles of gradualism to the realm of biology, made a crucial leap, arguing that the same forces that shaped the Earth also shaped life. This adaptation of Lyell's ideas, while not always precise in its scientific detail, demonstrated Chambers' ability to synthesize diverse scientific perspectives and forge new intellectual pathways. The influence of Vestiges extended beyond its immediate readership. While the book's specific mechanisms of evolution were later superseded by Darwin's theory of natural selection, it played a crucial role in preparing the intellectual ground for the acceptance of evolutionary thought. The book brought the concept of transmutation to the forefront of public discourse, familiarizing the public with the idea that species could change over time. This, in turn, paved the way for the reception of Darwin's on the origin of species 15 years later. Darwin himself acknowledged the importance of Vestiges in popularizing the idea of evolution, even while he criticized its scientific shortcomings. He understood that the book, despite its flaws, had helped to create a receptive audience for his own, more rigorously argued theory. The legacy of Chambers' work is complex. His specific scientific proposals were ultimately deemed inaccurate. His lack of scientific training led to inaccuracies and speculative leaps. However, his influence on the public understanding of science and the role he played in popularizing the idea of evolution is undeniable. He demonstrated the power of accessible writing to shape public discourse and to disseminate complex scientific ideas. His work serves as a reminder that the history of science is not solely the domain of laboratory experiments and mathematical proofs. It is also a story of ideas, of their dissemination, and of their impact on the broader culture. Chambers Robert, a man who stood at the intersection of science and society, provided a crucial contribution to this story. Having established Chambers' pivotal role in popularizing evolutionary thought, we now turn to the methodologies underpinning his groundbreaking work, Vestiges of the Natural History of Creation, This text, a cornerstone of 19th century scientific popularization, proposed a comprehensive theory of transmutation, meticulously weaving together diverse strands of evidence to support its central thesis that species are not immutable entities, but rather undergo gradual transformation over vast stretches of time. Chambers' approach, though lacking the rigorous empirical foundation of later scientific advancements, stemmed from a genuine desire to reconcile scientific observations with a broader understanding of the natural world. He confronted a significant intellectual challenge. The prevailing scientific consensus leaned towards fixity complexity of species, a view largely influenced by religious interpretations and the absence of a robust, widely accepted mechanism for evolutionary change. The dominant narrative held that species were divinely created in their present forms, a notion that presented a formidable hurdle to proponents of transmutation. Chambers addressed this problem by synthesizing diverse bodies of knowledge. He drew upon geological evidence, embryological observations, and speculative analogies to construct a compelling narrative of progressive development. His methodology hinged on the concept of a general law governing the development of all species, a unifying principle that linked the simplest organisms to the most complex, including humans. This law, as Chambers envisioned it, operated throughout the natural world, from the formation of planetary bodies to the evolution of life itself. A key component of Chambers' method involved the interpretation of the fossil record. He meticulously examined geological strata, noting the sequential appearance of different organisms. He presented this as evidence of a gradual unfolding of life, with simpler forms preceding more complex ones. For example, he cited the presence of specific fossil types in particular geological layers, arguing these demonstrated a progression of life forms through time. He understood the significance of these findings, even though the scientific community was still in the process of understanding the implications of this evidence. Embryology provided another crucial element of Chambers' argument. He observed the striking similarities in the early developmental stages of various animals, including humans. He saw this as evidence of a shared ancestry and a scale of being, a developmental trajectory that mirrored the evolutionary progression he proposed. He argued that the embryonic stages of an organism recapitulated, in a condensed form, its evolutionary history. For example, he highlighted the presence of gill slits in early human embryos, an observation that, for him, suggested a common descent with aquatic organisms. This utilization of embryological data to support evolutionary claims was a novel approach that resonated with a wider audience. To further bolster his case, Chambers employed speculative analogies, drawing parallels between the development of the Earth and the development of life. He proposed that just as the Earth had undergone a series of transformations from a molten state to its present form, so too had life evolved through a series of stages. He suggested that environmental factors, such as changes in climate and geological events, acted as catalysts for evolutionary change, driving organisms to adapt and evolve. This use of analogy, while lacking the empirical rigor of later scientific investigations, served to make his ideas accessible and compelling to a broad readership. The influence of the great chain of being and the concept of progression in nature is evident in Chambers' work. This philosophical framework, prevalent during his time, posited a hierarchical structure of life, with each organism occupying a specific rung on the ladder of existence. Chambers adapted this concept, integrating it with geological and embryological evidence to propose a dynamic, evolving chain where species ascended the ladder over time. This alignment with existing philosophical ideas contributed to the book's widespread appeal. Furthermore, Chambers' methodology was shaped by contemporary geological theories. He was influenced by the work of geologists who were beginning to understand the vastness of geological time and the dynamic nature of the Earth's surface. He incorporated these insights into his theory, arguing that geological changes provided the necessary environment for evolutionary processes to occur. The interplay of geological forces, in his view, was intrinsically linked to the progression of life. The enduring relevance of Chambers' methodology lies, in part, in the ongoing debate surrounding the role of analogy and speculation in scientific reasoning. While his specific mechanism for evolution proved to be inaccurate, his use of analogies and speculative reasoning served to open up the discussion surrounding transmutation. His work highlighted the importance of synthesizing diverse bodies of knowledge and of presenting scientific ideas in an accessible manner to a wide audience. This approach, while not without its limitations, underscored the power of popularization in shaping scientific discourse. Chambers' work, while ultimately superseded by more rigorous scientific theories, provided a crucial bridge between scientific inquiry and public understanding. He helped to popularize the notion of evolution, laying the groundwork for the acceptance of Darwin's theory of natural selection. His legacy is a testament to the power of ideas and their capacity to transform our understanding of the world. His approach, though marked by the limitations of his time, demonstrated the potential of accessible writing to disseminate complex scientific concepts and spark a profound shift in the way people perceive the natural world. The publication of Vestiges of the Natural History of Creation ignited a wave of intellectual curiosity, prompting readers to grapple with the very nature of life and its origins. Chambers, in his ambitious undertaking, sought to provide a framework for understanding the transmutation of species, a concept that, at the time, lacked a robust scientific mechanism. The absence of such a mechanism had previously hindered widespread acceptance of evolutionary ideas. He recognized the necessity of offering a plausible explanation for how one species could transform into another, a process that, if true, would fundamentally alter the prevailing understanding of the natural world. Chambers proposed a compelling, if ultimately incomplete, solution. He posited a force or tendency inherent within organisms, a drive towards progressive development, a striding towards more complex forms. This internal impetus, he argued, interacted with environmental influences to shape the trajectory of species. He envisioned a process where organisms, driven by this intrinsic force, responded to their surroundings, gradually accumulating changes that, over vast stretches of time, would give rise to new species. This internal drive, coupled with the pressures of the environment, provided the engine for evolutionary change. To bolster his claims, Chambers drew extensively on two key sources of evidenced embryological development in the fossil record. He observed striking similarities in the early stages of development across diverse animal species. These shared developmental pathways, he argued, pointed to a common ancestry, a shared evolutionary heritage. He noted, for example, the gill slits observed in the embryos of terrestrial vertebrates, a feature echoing the aquatic ancestry of these creatures. These shared characteristics, presented the early stages of development, served as tangible evidence, suggesting a gradual unfolding of life's complexity. The fossil record, with its catalog of extinct life forms, provided another crucial line of evidence. Chambers meticulously examined fossil discoveries, interpreting them as snapshots of the evolutionary process. He highlighted instances where fossils appeared to document the gradual transition of forms over geological time. These ancient remains, he argued, offered a glimpse into the past, revealing the progressive development of life from simpler to more complex organisms. He focused on specific examples, such as the fossil evidence of the early fish and their gradual transitions. These fossils, he believed, provided concrete examples of species transformation, supporting his vision of a constantly evolving natural world. Beyond the physical realm, Chambers extended his evolutionary framework to encompass the development of the human mind. He speculated on a connection between the evolution of the nervous system and the emergence of consciousness. He suggested that the increasing complexity of the brain correlated with the development of higher cognitive functions, including thought, reason, and self-awareness. This speculative leap, while controversial, reflected his holistic approach. His belief that the laws governing the physical world also extended to the realm of the mind. He perceived the human mind as the pinnacle of this evolutionary progression, the culmination of a long and intricate process of development. Chambers's work was deeply influenced by the intellectual currents of his time. He drew upon contemporary theories of natural philosophy, which often emphasized the interconnectedness of all things and the existence of underlying forces governing the natural world. The concept of vital forces, which posited that living organisms possessed inherent properties that distinguished them from inanimate matter, also played a role in shaping his thinking. These ideas, prevalent in the scientific and philosophical discourse of the era, provided him with a framework for understanding the driving forces behind evolutionary change. Chambers's work, while not a perfect scientific model, had a lasting impact. His synthesis of embryological evidence and the fossil record, although presented without the benefit of modern genetic understanding, highlighted the importance of these fields in understanding the history of life. The ongoing discovery and analysis of fossils continued to provide invaluable insights into the evolutionary process. The study of embryology, too, remains a vital field, revealing the genetic and developmental mechanisms that shape the diversity of life. These areas, central to modern evolutionary biology, owe a debt to the pioneering work of Chambers. The debate concerning the interplay between environmental and genetic factors in species development, a central theme in Chambers's work, continues to be a subject of active research. Scientists continue to explore how environmental pressures, such as climate change and resource availability, interact with genetic variation to shape the evolution of populations. The study of epigenetics, the study of how environmental factors can influence gene expression, has further deepened our understanding of the complex relationship between environment and inheritance. Chambers's exploration of the relationship between mind, matter, and evolution also resonated with subsequent thinkers. His work sparked interest in the development of theories of consciousness and the ongoing debate about the nature of the mind. The exploration of the evolutionary origins of consciousness, a field of study that seeks to understand how consciousness emerged through natural selection, reflects the enduring influence of Chambers's ideas. The legacy of Chambers lies not in the specific details of his proposed mechanisms, which were later superseded by Darwin's theory of natural selection, but in his pioneering effort to synthesize disparate bodies of scientific knowledge into a coherent and accessible narrative. His work, though debated, sparked a vital conversation about the very nature of life. His work demonstrated the power of bringing scientific ideas to a broad audience, setting the stage for a more informed and engaged public discourse concerning the natural world. His efforts to explain the world in an accessible manner, using evidence from diverse fields, sparked the imaginations of countless readers and laid the groundwork for the widespread acceptance of evolutionary thought. The impact of his work is a testament to the power of ideas and their remarkable capacity to transform our understanding of the world. The publication of Vestiges of the Natural History of Creation, published 1844, ignited a firestorm of controversy. The book's central thesis, that life had evolved over time, challenged both scientific and religious orthodoxies, provoking a diverse range of reactions. The scientific community, still largely wedded to fixity of species, viewed Chambers's ideas with skepticism, while the religious establishment saw in them a direct assault on the biblical account of creation. The book's anonymous authorship, initially a source of speculation, added an element of intrigue to the debate. It quickly became a topic of conversation in drawing rooms, coffee houses, and scientific societies alike. Initial reviews, appearing in both scientific journals and popular periodicals, reflected the deep divisions within Victorian society. Many critics, especially those aligned with established scientific authorities, attacked the book's lack of rigorous scientific methodology. For instance, a review in the Athenaeum a prominent literary journal, dismissed Vestiges as a work of unscientific speculation, pointing to the author's reliance on anecdotal evidence and speculative reasoning. The reviewer, echoing the sentiments of many scientists of the time, questioned the validity of drawing sweeping conclusions from limited observations. The lack of empirical data to support the proposed transformations was a frequent point of contention. Yet, the book also found defenders. Some reviewers, particularly those sympathetic to the burgeoning field of scientific naturalism and the broader progressive movement, praised its boldness and accessibility. They saw in Vestiges a valiant attempt to synthesize scientific knowledge and challenge the prevailing conservative worldview. These reviewers, often associated with the more radical and progressive intellectual circles, appreciated the book's attempt to unify diverse scientific disciplines under a single, overarching theory. The book's accessible style, which made complex scientific ideas understandable to a wider audience, was another point of commendation. This style, which included vivid descriptions and compelling narratives, helped to popularize scientific concepts and make them more widely known. The debate extended beyond the confines of scientific journals. Vestiges became a subject of heated discussion in the social press, fueling public interest in the relationship between science and religion. Religious leaders, alarmed by the book's implications, condemned its arguments from the pulpit. Sermons and pamphlets were produced, warning against the dangers of secularism and the erosion of faith. These responses underscore the profound cultural anxieties surrounding the rise of science and the perceived decline of traditional religious authority. The book's challenge to the literal interpretation of the Bible provoked intense backlash. One of the most vocal critics of Vestiges was Adam Sedgwick, a prominent geologist and a staunch opponent of transmutation. Sedgwick, a respected figure in the scientific community, devoted considerable energy to attacking the book. His review, published in the Edinburgh Review *, was a scathing condemnation of Chambers's work. Specifically, Sedgwick criticized the book's lack of scientific rigor, its reliance on speculative arguments, and its perceived threat to religious belief. He characterized the book as a dangerous work that undermined both science and religion. Sedgwick saw the book as a threat to the established order and a source of intellectual confusion. His influential position within the scientific establishment lent considerable weight to his criticisms. Conversely, some reviewers, though fewer in number, saw merit in the book's ambition to connect diverse fields of scientific inquiry. They recognized the significance of the concept of evolution, even if they disagreed with the specifics of Chambers's proposed mechanisms. These individuals, often associated with the more progressive elements of society, appreciated the book's attempt to integrate scientific knowledge and challenge the prevailing conservative worldview. They viewed the book as a step towards a more rational and scientific understanding of the world. The book's accessibility, which made complex scientific ideas understandable to a wider audience, was another point of appreciation. The controversy surrounding Vestiges did more than simply expose the scientific and religious divisions of the era. It also highlighted the growing importance of public opinion in shaping scientific discourse. The book's popularity, despite the criticisms leveled against it, demonstrated the public's increasing interest in science and its willingness to engage with complex scientific ideas. This phenomenon, which saw a broad interest in scientific ideas, played a crucial role in paving the way for the later reception of Darwin's * on the origin of species *. The book's success in attracting a wide readership underscored the power of popular science to influence public perceptions and contribute to the advancement of scientific ideas. The debates surrounding Vestiges also had a significant impact on the development of scientific methodology. The criticisms leveled against the book, particularly the accusations of speculative reasoning and a lack of empirical evidence, served to reinforce the importance of rigorous scientific investigation and the need for verifiable data. This emphasis on empirical evidence, which became a cornerstone of scientific practice, was a direct consequence of the controversies surrounding Vestiges. The book's reception, therefore, provides a valuable case study in the complex interplay between science, society, and culture. The initial reaction to Vestiges reveals the deeply intertwined nature of scientific and religious beliefs in the Victorian era, highlighting the challenges faced by those who dared to challenge established orthodoxies. The book's widespread impact, which extended far beyond the confines of scientific circles, underscores the power of scientific ideas to shape public opinion and influence the course of intellectual history. The controversy surrounding Vestiges served as a crucial precursor to the later acceptance of evolutionary thought. The book effectively prepared the public for the more scientifically grounded arguments that would eventually be presented by Charles Darwin. The legacy of Robert Chambers, therefore, extends beyond the specific claims advanced with an Vestiges of the natural history of creation It resides in the profound impact the work exerted on the public understanding and reception of scientific ideas during a period of significant intellectual upheaval. The book's appearance, a catalyst for both acclaim and condemnation, provides a valuable lens through which to examine the complex relationship between scientific inquiry, societal values, and the evolution of thought. The problems Chambers addressed, the questions of origins and the development of life, resonated deeply with a society grappling with the implications of scientific progress and the erosion of traditional beliefs. His methodology, though lacking the rigor of scientific investigation, lay in synthesizing existing scientific knowledge, popularizing it, and presenting it in a compelling narrative accessible to a wide audience. This approach, though criticized by many scientists of his time, proved remarkably effective in sparking conversation and shaping the cultural landscape. Specific examples of Vestiges applications are numerous. The book's influence can be observed in the debates that unfolded within scientific societies, in the pages of popular journals, and in the broader public discourse. The book's appearance prompted a flurry of responses, ranging from enthusiastic endorsements to scathing critiques. The discussions that followed, centered on the validity of the transmutation of species and the relationship between science and religion, helped to prepare the ground for the acceptance of more rigorously argued evolutionary theories. The book's impact is evident in the transformation of public perceptions regarding the natural world. It helped to erode the rigid boundaries between scientific and religious explanations of the universe. The modern relevance of Chambers's work lies in its continued illumination of the dynamics of scientific popularization and public engagement with science. The challenges Chambers faced in presenting his ideas to a skeptical audience and the controversies that ensued offer valuable lessons for scientists, communicators, and educators. His experience highlights the importance of clear communication, the need to address public concerns, and the crucial role of popular science in bridging the gap between the scientific community and the broader public. The legacy of Vestiges serves as a reminder of the power of ideas to shape public opinion and influence the course of scientific progress. The broader intellectual history of the 19th century, with its burgeoning scientific naturalism and the challenges to religious beliefs, acted as a direct influence on Chambers. The rise of scientific societies, the increasing availability of scientific knowledge, and the growing acceptance of empiricism all contributed to the intellectual climate in which Vestiges found its place. The work of earlier naturalists, such as Erasmus Darwin and Jean-Baptiste Lamarck, directly influenced Chambers's thinking, providing him with the intellectual framework for his own speculations on the transmutation of species. These thinkers, who proposed transformative ideas about the natural world, laid the groundwork for Chambers's own explorations. The impact of Vestiges on others is perhaps its most significant legacy. The book's widespread readership, extending far beyond scientific circles, helped to pave the way for the eventual acceptance of Darwin's theory of natural selection. It familiarized the public with the idea of evolutionary change, preparing them for the more scientifically rigorous arguments that would follow. The controversy surrounding Vestiges served as a crucial precursor to the scientific revolution that Darwin Darwin's work would ignite. The book's success in capturing public attention and the subsequent debates it generated demonstrated the power of scientific ideas to shape public opinion and influence the course of intellectual history. Chambers' work, despite its shortcomings from a scientific perspective, served as a critical step in the evolution of scientific thought. His efforts to popularize scientific ideas, even if his own theories were eventually superseded, played a crucial role in preparing the public for the acceptance of Darwin's theory. The book prompted a widespread discussion of evolutionary concepts and helped to create an environment in which Darwin's work could flourish. Vestiges, therefore, can be understood as a significant contribution to the history of science, not for its specific scientific claims, but for its success in shaping public discourse and influencing the reception of scientific ideas. The controversies surrounding Vestiges also highlight the complex interplay between scientific inquiry, societal values, and the evolution of thought. The initial reaction to the book underscores the deeply intertwined nature of scientific and religious beliefs in the Victorian era. The book's widespread impact, which extended far beyond the confines of scientific circles, demonstrates the power of scientific ideas to shape public opinion and influence the course of intellectual history. The impact of Vestiges on scientific debates and public discourse is undeniable. Chambers' contribution should be assessed within the context of the broader intellectual landscape of the 19th century. The rise of scientific naturalism, the challenges to religious beliefs, and the increasing importance of empiricism all contributed to the intellectual climate in which Vestiges found its place. The work of earlier naturalists, such as Erasmus Darwin and Jean-Baptiste Lamarck, directly influenced Chambers' thinking. These figures provided him with the intellectual framework for his own speculations on the transmutation of species. The reception of Vestiges can, therefore, be viewed as a valuable case study in the complex interplay between science, society, and culture. The initial reaction to the book reveals the deeply intertwined nature of scientific and religious beliefs in the Victorian era. The book's widespread impact, which extended far beyond the confines of scientific circles, underscores the power of scientific ideas to shape public opinion and influence the course of intellectual history. The controversy surrounding Vestiges served as a crucial precursor to the later acceptance of evolutionary thought. The book effectively prepared the public for the more scientifically grounded arguments that would eventually be presented by Charles Darwin. In conclusion, Chambers' work, though flawed in its scientific details, holds a significant place in the history of science. His efforts to popularize scientific ideas and the controversies they sparked helped to shape public discourse and prepare the ground for the acceptance of evolutionary theory. The legacy of Vestiges resides in its impact on the public understanding of science, its role in the development of evolutionary theory, and its enduring lessons about the relationship between science, society, and culture. The echoes of the debates surrounding Vestiges can still be heard in contemporary discussions about science, communication, public engagement, and the ongoing evolution of scientific thought.
We really appreciate you tuning in to this AI-powered presentation. Our goal is to push the boundaries of AI in content creation, and your input is invaluable. If there's a particular subject you'd like to see us tackle next, or if you have suggestions on how we could fine-tune our AI's creative prompts, please don't hesitate to leave your ideas in the comments section. We're excited to bring you more unique content very soon.